Hello everybody and welcome back. Today we are going to continue our lesson and talking about our tides. So we've already done the seasons, so now we can talk about the tides and the effect that the moon has on our tides. So when I refer to the tides, I'm sure most of you have been to the beach. If you haven't, if you go to the ocean, about every 6 hours the tide will come in and out. So when you wake up in the morning, the tide might be really high, and if you go down to the beach, the water and the ocean is very far up on the shore. And then maybe you swim a little bit and then take a break, go have lunch, and then go back to the beach, and you notice that the tide is actually further out and lower on the shore. So why is that? Well, we're going to learn about that today. I'm not going to play this video, but it's a really good one if you want to watch an explanation on the tides, but I'm going to go over your notes with you as well. So our moon, again, is a satellite. It's a natural satellite, and its revolution around our Earth takes about 1 month, so 29.5 days. And the moon is spinning and revolving the way that the Earth does as well. And we only ever see one side of our moon because of this. So because it's spinning and because the revolution takes 1 month, we only ever see one side of the moon. So if you ever hear anybody refer to the dark side of the moon, it's because we just can't see what's on the other side. And if we refer to a perigee, that is when it's closest to the Earth, and then an apogee, that's when it's furthest. I'm really not super concerned about you guys knowing that. That's just a little tidbit of knowledge for you. These are the phases of the moon. I don't need you to really necessarily know these by heart. What we're going to be focused on for the tides are the new moon. And the new moon is when basically it's nighttime, so when it's not getting sunlight shining on it. So new moon is when we don't see the moon. First quarter is when we see half of it. Full moon is when you can see the whole moon. And then third quarter is again when you can see kind of the left half of the moon. You don't really need to know the moon phases. I'm not going to ask you about the phases of the moon. What I am going to ask you about is how the moon affects the tides. Okay? So what is a tidal bulge? So a tidal bulge is just thickening of water near the equator because of a gravitational pull from the moon and the sun. So remember, anytime that two objects are near each other, so anytime two celestial bodies are near each other in space, they work on each other from gravity, right? So gravity pulls on them. So we've got the moon, that's a natural satellite of Earth, that is revolving around our Earth. And as it revolves, it pulls, right? So the force of gravity attracts the water and kind of the force of the Earth towards the moon. So because of this gravitational attraction, the oceans and the water moves in tandem with this. So we see a bulge as the gravity pulls the center of the Earth towards the moon. And there is an equal and opposite force on the other side. So we've got two bulges. So one towards the moon and then one on the direct opposite side of the Earth. So again, here's how we would see our tides. So when the moon is in alignment, so on whatever side of the Earth that the moon is in position at, that is where your high tide is going to be, okay? So if we're looking at this diagram, the moon is right here. It is pulling on the center of the Earth. So your high tide is going to be on the side where the moon is. And then we've got this opposite force on the other side, okay, on the direct opposite side of the Earth. And we will also have a high tide because this bulge is opposite across the Earth, okay? So our high tide is going to follow the position of the moon, and then our low tide will be perpendicular. And then again, here is that diagram. We've got the gravitational pull of the moon that's causing this bulge. And then there's the opposite bulge on the other side of the Earth. So we see our high tide in line with the moon and on the opposite side of Earth. And then our low tides are perpendicular to the moon. Now, our sun also has a gravitational pull on our Earth, and it can affect our tides. So there's a sun tide and a moon tide. However, even though the sun is very large, it's a lot further away than our moon. Okay, so our moon is going to have more of a gravitational effect than our sun will. Okay, but depending on where the sun and the moon are in alignment during our rotation and our revolution, there will be kind of some different effects on our tides. Okay, so the tides are just caused by the attraction of the moon and the sun, and they occur about every 12 hours. Okay. So on the side of Earth closest to the moon, the pull is greater, so water will pull in that direction. So again, we have high tides on the side that is closest to the moon. And then this bulge will stay in place, and what we'll see is that as our moon moves, the bulge will go with it. Okay. We need to be aware of something called a spring tide and a neap tide, and we need to know the difference. So during a spring tide, it's the tide that occurs just after a new or a full moon, and this is when the moon is in alignment with the sun. So what I mean that is that the moon, the sun, and the earth are all in perfect alignment with each other. So we've got our sun and then our moon. It can either be between the sun and the earth, or it can be on the opposite side of the earth. It doesn't matter the position. It just matters that they are all in alignment. So when this happens, the gravity of the earth, so the gravitational pull of the moon and the sun working on the earth, will create higher high tides and also lower low tides. So during a spring tide, you will see higher tides, higher tides, and lower tides because of the increased gravitational pull that's working on the earth. Now during a neap tide, this is kind of the opposite. So we've got our moon perpendicular to our sun, so their gravitational pulls are kind of working opposite each other. So this occurs after the first or the third quarter moon, so that's when we see half of the moon. Okay, and there is a least difference between the high and the low water. So what this means is that you would see actually a lower high tide than normal and a higher low tide than normal. So during a spring tide, again, that's when they're all in alignment, you would see the tides kind of on the extreme end. So they'd be really, really high and really, really low. And then during a neap tide, during the quarter moons, when you look up in the sky and the moon, you can see half of the moon, then you're going to have less of a difference between the tides. So the difference will be a little bit more subtle. So we do need to know the difference between the spring tide and the neap tide, and we need to know the position of the moon and the sun during that. Okay? So again, during a spring tide, we've got the sun, the moon, and the earth all in alignment. And during a neap tide, the sun, the moon, and the earth are perpendicular. Okay. And then this is just showing kind of the same thing. So during our spring tide, our moon is aligned with the earth and the sun. So we've got that higher gravitational force going at work. And then during a neap tide, we have it perpendicular, so you won't notice as much of a difference between the tides. And here's another little informational video that can help. And then here is a depiction. So this would be on the same day, right? As our moon is revolving around our earth, changing our tides. During high tide, it would be just the state of the tide when it's at its highest level. And then low tide is when the tide is at the lowest, right? So this is the same beach in the same place on the same day, just at different times. And then this shows you kind of the oscillation. So high tide, low tide, high tide, low tide. I'm not really sure how it works, but they do have clocks that will tell you when it's high and low tide. My grandmother has a beach house, and ever since I was little, she had this little clock in there that would tell you if it was high or low tide. And I thought it was the coolest thing. So what does this mean? Basically, you just have to be careful if you are, well, looks more like a flash flood than a tide. But just being aware and noticing what's going on now when you go to the beach, and like if you ever go hang out with your family, you can explain what actually affects the tides. And then here, like this person this is probably during a spring tide, right? When the water will come up and be very, very high. My grandmother's beach house is on like a waterway, a canal. And during spring tides, typically what will happen is that the tides will get so high that the backyard of the beach house will get flooded, because you do see those higher tides. and you can't really walk in the yard because there's water everywhere. So just something to be aware of. The main takeaway I want you guys to know about the tides is that the gravitational force of the moon is what causes the tides, and the tides will be highest on the side of the earth that is facing the moon and on the opposite side. Okay, so it's an equal bulge. So the side facing the moon has the high tide, and on the opposite side the earth, and then the other sides have the low tide. And that bulge and those high tides will follow the moon as it revolves around the earth. And then I need you guys to know that a spring tide occurs when the earth, the sun, and the moon are in alignment, and that's when you get really high tides and really low tides. So low tides and high tides. And then in a neap tide, the moon, the sun, and the earth are in a perpendicular angle, and that's when we see a more subtle distance. So we've got higher low tides and lower high tides. All right, so that's it for today. If you guys have any questions, make sure you reach out and let me know. But if not, we are well on our way to wrapping up our astronomy unit.